Auroras in Mexico a few weeks ago. Last year, all of mainland Spain could see them when looking north. These events are supposed to be very rare at such low latitudes, something that happens only once every several decades. But in these last few years, it seems that something strange is happening. And in fact, the activity recorded in this solar cycle is much higher than what the predictions indicated. Some scholars are beginning to suspect that we might even be witnessing the end of the Gleisberg cycle, entering unknown territory. What is happening with the Sun? We need perspective, a bit of context to better understand the seriousness of what is currently happening. These anomalous auroras are caused by very strong geomagnetic storms, which are severe disturbances of the Earth's magnetic field. Caused, literally, by pieces of our Sun, ejected in the form of plasma, that reach us here on Earth. And let's remember that essentially the Sun is a titanic nuclear reactor that has been reacting for billions of years. There is so much energy contained in it that from time to time a little escapes into interplanetary space. And when we're unlucky enough that our orbit intersects with that coronal mass ejection, that's what they're called, a geomagnetic storm occurs. These ejections are made up of very hot protons and electrons that travel at extremely high speeds. It's a wave of trillions of tiny bullets, but with a lot of energy traveling toward Earth. Yes, they're very small, but there are a lot of them. If we didn't have a magnetic field, they would strip away the upper layers of the atmosphere, dragging tons of the atmosphere off into deep space, and at the same time destroying a considerable part of the ozone layer. 4 or 5 strong coronal ejections without the protection of the magnetic field would be enough to leave us without an ozone layer for many years. It would be very risky to go outside. The frequency of burns and cancers would skyrocket abruptly, but the magnetic field protects us. It's like a cushion that absorbs the force of these bullets. This causes the magnetic field to contract during geomagnetic storms, just like a flexible shield would if it were hit by many bullets. And this contraction can be measured to assess the severity of a storm. This is what's known as the DST index. When there are no active geomagnetic storms, the shield is calm. And the DST is at 0, fluctuating at most to +20 or -20. From -50 onwards, it's considered that we're in a moderate storm. They're negative units because the shield thins out when it gets hit by solar bullets. -100 is already an intense storm, and a superstorm is from -250 onwards. The largest geomagnetic storm ever recorded was the infamous Carrington Event in 1859 with a DST of -1760. Auroras were observed all over the world, both in the northern and southern hemispheres. The northern lights over the Rocky Mountains in the United States were so bright that the glow woke up the gold prospectors, who started preparing breakfast because they thought it was already dawn. And in the northeast of the country, it was reported that people could read a newspaper in the middle of the night thanks to the light of the aurora. The aurora was also visible in areas of very low latitude, such as southern Mexico, Cuba, or Hawaii, and even in very low latitudes close to the equator, like Colombia. But it wasn't all pretty colors. The friction of the coronal mass ejection particles with the magnetic field was so high that electricity was generated in the air, and telegraph systems throughout Europe and North America failed, in some cases causing electric shocks to their operators. The telegraph poles emitted sparks, and some operators were even able to continue sending and receiving messages despite having disconnected their power sources. There is a record of a conversation that lasted for approximately 2 hours, without using any battery or artificial power source, operating solely with the current induced by the storm. This was the first time in human history that information was transmitted over long distances almost instantly without using man-made electricity. If this happened today, the consequences would be much worse, even if we aren't aware of it. And that's because we live in a technological civilization whose foundations we barely understand. -1760 DST, we have the context. Last year, in May 2024, a DST of -412 was reached, the most severe in the last 10 or 20 years. Although it was 4 times less powerful than the Carrington Event, it was still a monstrous storm. Many satellites had serious problems. Tractors in many parts of the world started behaving erratically due to GPS failures. Some power lines had to be shut down as a precaution, and several telecommunication systems failed. I myself experienced network connection problems, and when I mentioned it on Twitter, several people shared the same experience. Although this doesn't confirm the cause, it was very suspicious. And while we're at it, this is the photo I took myself from Barcelona, Spain. It was truly, honestly fascinating and somewhat terrifying. I have very vivid memories of that night. And on November 11th of this year, 2025, there was another storm, a bit weaker, that produced auroras all over North America, including Mexico. Are we on the verge of another Carrington event? Or something worse? Today's civilization is much more dependent on electricity than it was in 1859. A storm of such magnitude nowadays could be almost apocalyptic. And to calculate the probability of this happening, we need to understand the so-called solar cycles well. These are periods of 11 years during which the number of sunspots and solar eruptions, the levels of solar radiation and coronal mass ejections show synchronized fluctuations, beginning with minimal activity, peaking midway, then dropping back to a minimum by the cycle's end before repeating. In other words, the sun goes to sleep and wakes up in 11-year cycles. The thing is, it doesn't always wake up with the same strength, it goes through phases. During several consecutive cycles it's calm, and other times also consecutively it becomes hyperactive for several cycles. A very good way to visualize and calculate the intensity of these cycles is to add up the total number of sunspots per cycle, because, as I mentioned before, everything is connected. If there are many spots, there are many coronal ejections. That's what you're seeing here. On the vertical axis, the number of sunspots counted each year. On the horizontal axis, the years. As you can see, the solar cycles are very evident. They're these mountains that rise and fall every 11 years. The red part is because before 1750 there weren't good enough instruments to count the spots with the same accuracy as today, so it's set apart. It's indicative, but you can't take it literally. But it's important because the solar cycle started being counted from then on. Now we're in cycle XFV. In any case, the most relevant thing here is the oscillations of the cycles in the long term, which also have a certain cyclicity. Notice that the calmer cycles and the more active ones are grouped together. It's not random. The Dalton minimum, for example, was a period between 1790 and 1830 during which solar activity, even at the maximum of each cycle, was much lower than normal. But then came a maximum, and that's when the Carrington event happened. And now, where are we? Well, basically in the 2000s we came out of the modern maximum, giving way to a new minimum. That is, in recent decades we've entered a zone similar to the Dalton minimum, so we could be at ease. This seemed to be confirmed by cycle 24, which was quite mild. The monthly maximum of sunspots was 170 in February 2014. However, the anomaly is happening with the current cycle, number 25. In August 2024, the solar cycle reached its maximum, which is why shortly after there was the major geomagnetic storm with auroras in Spain. And now, a year later, we're still pretty high in the cycle. That's why there are auroras in Mexico. However, this hasn't been a standard cycle maximum. At the peak, a total of 245 sunspots were counted, which is much higher than what would be expected if it were a cycle from a period of quiet cycles, following the trend of the previous cycle, the 24th. Three things could be happening. One, that we're not really entering a minimum like the Dalton minimum, but rather that the last cycle was an anomaly within a maximum that has still been ongoing since before the year 2000, like what happened in the 20th century, which was also unusually low. This would be something concerning because it would mean that the next cycle could be very powerful. 2. Exactly the opposite, that we are indeed in a minimum and this is just a small anomaly. This is the best scenario, since in the coming decades we would be calm. And 3. We have no idea whatsoever about what's going on. This wouldn't be so strange, since in the end we only have records of 25 solar cycles, which isn't enough time to have studied the sun well and predict all its patterns. For now, cycle XXV is already entering its inactive phase, so at least we'll have a few years of peace. Everything will depend on how cycle XXV behaves. Thank you very much for watching the video, and goodbye.